Okay, here we go. Cool. All right, 120 exactly. So let's start here. Okay, hi. My name is Paul Sztorc. I've been a Bitcoiner since 2012. This talk is for the Bitcoiners, so if you're not a Bitcoiner, just continue to not pay attention, and it'll be great. And I published Bitcoin research on my blog, truthcoin.info, since 2014. Truthcoin's my Twitter handle. It's a long story, but that's a project we'll get to at the end of this presentation. I presented at a lot of Bitcoin conferences, especially the scaling conferences, as well as building on Bitcoin last summer, TabConf earlier this year. I currently work for Tierion as a research director. Before that, I worked a kind of pre-doctoral research statistician job at the Yale Econ department for a man named William Nordhaus, who won the Nobel Prize in economics a few months ago. So the topic of this presentation is a Bitcoin layer 2 solution called Drivechain. These days I sort of call it a layer 1.5 solution because it kind of sneaks in between layer 1 and the Lightning network. You see, everyone is calling Lightning layer 2, and Lightning can go on top of this, so it has to kind of fit in between. Plus, each Drivechain is a layer 2 of BTC, but it's also a layer 1 of its own blockchain, so is it a layer 1 or not? It's kind of like a 1.5 is how I deal with that. So Drivechain aims to provide scalability and interoperability, and it can be deployed by a soft fork. It's very slowly being assigned BIP numbers 300 and 301. The project website is drivechain.info, and if you are technical, I highly recommend you read the BIPs. Otherwise, I would just recommend browsing drivechain.info because there's tons of information there, especially the FAQ. Here is the talk in one slide, if that's possible. The problem is meta-consensus. So consensus is getting all the nodes to look the same way, and we know how to do that. But meta-consensus is having humans agreeing on what the node should be agreeing about. So it's consensus about consensus. And examples of this include the block size debate, SegWit, check lock time verify, other changes to Bitcoin, and other every hypothetical change to Bitcoin, including like Turing complete scripts, Mimblewimble, whatever. So we know how to get the nodes to agree with each other, that's consensus, but we don't know what to do when humans disagree about what the nodes should be doing. So that's when that happens, we get altcoins and hard forks, or we miss out on good features maybe. So the solution is just have one token that travels among many blockchains, and this idea used to be called sidechains, but that word has almost no meaning today. It is now used to describe even things that are not blockchains at all, let alone what the word originally meant, which was a very specific and new type of blockchain. So the word sidechain probably just causes confusion at this point. Anyway, so in a sentence, we're just going like, why settle for the best features, which is Bitcoin Core, of course, but when instead you can have every feature. So why compete to win when you can just play all the hands? That way you'll never lose. And the implication is, of course, the death of the altcoins, including Ethereum and Ripple and all these other projects that have gigantic market capitalization. So it's kind of an interesting idea. So how is it? I'm going to try to explain how this works via example, but I have a couple paragraphs before the example. So this soft fork allows a new kind of output that I call hash rate escrow. Anyone can put BTC into it, but money can only be taken out of it in a very strange way. Miners can take it out and send it wherever they want, but they can only extract it very, very slowly and transparently, very slowly, 3 to 6 months. So instead of paying money to a person, you kind of put it into this kind of process. I don't know why the microphone is doing that. And I have this kind of prison metaphor here. And metaphorically, the escrows are kind of like prisons where the miners are like the warden. You can choose to go in at any time, but it's hard to get out. So I'm sure this doesn't make any sense to anyone, so I have this example. And you start with Bitcoin Core, and this is what it looks like, if you didn't know that. And then we have our soft fork to add BIP 300 and 301, and it adds this little tab over here. The guy who does all the real work on this project, Cryptax, he loves Qt, and he made all these themes for Bitcoin, including this dark theme. So as a bonus, you get cool themes, which is why it's dark. Roger Ver, step 3, you have a meta-consensus problem. Roger Ver disagrees with the consensus rules of Bitcoin Core, specifically the 1 megabyte block size limit. And so Roger gets together with a bunch of friends, and they form a new community. And they create a new blockchain using our template that has the consensus rules that they want, which is that the higher block size. And you see this piece of software is red. It's different from the previous version. The previous version was core plus BIP 300-301, and this version is a sidechain template, so you have to pay attention to the circles. The first software is specialized to have multiple hash rate escrows, still call them sidechains, and the template is specialized to have one parent chain, so you see the green circle. Anyway, Roger and friends, they call the new piece of software Bitcoin Payments, and as with Lightning and other layer 2 stuff, Bitcoin Payments is always watching Bitcoin Core, and it requires a Bitcoin Core full node. So next, Roger adds a new escrow, a new prison thing to Bitcoin Core, and they tie this escrow to the payments chain. Maybe you can see here there's fields for sidechain address bytes and tarball hash and things to tie the software to the software, which is a completely different piece of software, to the prison output that exists in BTC. Anyway, then in this example, Roger is going to use this kind of like Bitcoin Cash. So he's going to send 50,000 of his BTC from layer 1, which is Bitcoin Core, into the prison on layer 1. But then he's going to get credit for it over in Bitcoin Payments land. So 50,000 BTC shows up over there. And you can see at the top, I'm keeping track of what happens on layer 1, and only one transaction is going to be happening there for a while. In fact, I actually added another one. But so these transactions are unremarkable. Going into the prison is just like spending to a SegWit output or spending to a P2SH output or sending to a normal person. So it's totally unremarkable, but I think I added one. Yeah, I added one with Brian Armstrong also going in. And these are going to be the only two outputs for a little while. Now, Roger is going to go all around the world giving away free Bitcoin, convincing people to download the Bitcoin.com wallet, etc. But when he gives away Bitcoin, it's going to be on this layer 1.5 inside the prison. So nothing is happening on layer 1, so onboarding is actually very easy. Okay, this is important though. The transactions in the prison don't show up on layer 1, but the transaction fees do show up on layer 1 due to something called blind merge mining. And 20 minutes really isn't enough time to explain both, but in one sentence I'll just say that the act of finding the merge mine block, of tracking what happens in the prison, that is transformed and compressed into the act of including a single layer 1 transaction on a BTC. So when lay people want to get out of the prison, normal people want to leave, that would be you in the audience, you want to leave the prison, you can use these atomic swaps or a service like Shapeshift or SideShift in the example here. It charges 1%, but you get out of prison immediately, so it's kind of like a prisoner exchange or something. You sign over the incarcerated coins to Andreas, to someone else, and he gives you layer 1 coins in return. So you can see on layer 1, Andreas is giving you, if your name is Jeff, I don't know, I just picked that name out of nowhere. That's no one. So eventually, you reach a point where all these people, Andreas and Eric Voorhees, have everyone's coins, and they want to get out of prison, so how do they do it? They submit these requests, which are these little bubbles here, and the software, the Bitcoin payment software, looks at all the requests and aggregates them into a type of transaction that it's going to need, and it defines that by just tiny 32 bytes. And then, well, you can see this is where the 32 bytes are in the escrow, in the new piece of software, in Bitcoin payments that Roger Ver made in the previous example. And they're going to be in every header of Bitcoin payments block for as long as it takes until the withdrawal either goes through or until it fails. So the next step is that a Bitcoin Core miner puts a coin in the Coinbase message. He puts these 32 bytes into this first gate here, and then in the next block it either moves forward a gate or back a gate, or it stays where it is, and miners control where it goes. But there's very, very many gates. There's 13,150 gates, and so this takes about 3 to 6 months, and if the bytes make it all the way to the last gate, then a transaction matching the ID can be included on layer 1, and the funds get out, and then Eric and Andreas are happy, and everyone is happy. So that is the example. And I'm going to now go into like the costs and risks of doing this so that you can see if this idea is even worth learning about or paying any more attention to. Any funds sent into an upper layer, they have to deal with the new security considerations of that layer, right? So in the Lightning Network, for example, you have a lot of new things to worry about. You need to be able to notice fraud very quickly, possibly by relying on watchtowers. You need to be able to broadcast a layer 1 transaction in time to prevent any theft. It's the second thing of your coins. And you need that broadcasting needs to be economical for you. And then a third, you need to be able to wait out the custodial period if your counterparty goes AWOL. So these are just the challenges of using Lightning. They're just inherent to that specific idea. In Drivechain, you also have something new to worry about, which is that you have to worry about if the escrows or the prisons, if they're really adding value for miners. And specifically, you want the one that you're in to really be adding a lot of value for miners. And I'll get to that in a second. But if Drivechain is a very popular feature in general, then you'll be very comfortable and everything will work. The escrows will be boosting the value of BTC and contributing a lot of transaction fees. So the miners will want the escrows around, and I'll get to that in 2 slides. But if miners don't want the escrow around, then they can withdraw all the BTC themselves. All they have to do is figure out exactly how to divide the money that's in there amongst themselves. And in this example, I've just given it all to Jihan Wu as a kind of joke. And they calculate which 32 bytes would correspond to him getting all of the money. They put those 32 bytes into their first gate, and then they're going to walk it through over 3 to 6 months. But what I want to point out is that all of the users of Bitcoin payments are going to know immediately, and because of Twitter and Reddit, everyone else will also know. And this includes people who want to just point and laugh at this thing as it in slow motion explodes. But it also includes people who are using other layer 1.5, other escrows, and who might be concerned that they will be the next victims. And it includes people who have never used any of this for anything, but who thought that they might use it in the future. So it could potentially be seen as impolite or inhospitable. But yeah, over the next 3 months, they're going to walk the wrong 32 bytes in full view of everyone. And this is only if you have 100% of the hash rate, because remember, you can't actually set it back. So it may take much longer, 6 months, or it may never happen. But you can march it through these gates here, and then if they make it out, then Jihan Wu gets all of the money. And you can see that in layer 1, he takes it out of that gray output. I have other pots. So all 50,000 of the Bitcoin that Roger originally deposited to the escrow goes to Jihan Wu. And the fact that Roger maybe sent it to thousands of people in the intervening time, it doesn't make any difference. So layer 1 has no idea what layer 2 is doing, and that is the bad news. So in summary, the idea is a lot like this, where you have you create these new blockchains for people to use, which whatever consensus rules that they want to have. And if people use them, this adds value to miners. So it's both directly in the form of more transaction fees, but also indirectly, because a BTC that can do anything it should be more valuable than a BTC that can only do one thing. So, and then number 2, you give miners a choice of that you can either take this revenue or you can destroy it. You can kill the goose that lays the golden egg, so to speak. And then number 3, you make the system extremely auditable by reducing all of the economic activity in the prison down to a few net transfers, which can be undertaken by specialists like the Eric Voorhees Andreas example I showed you earlier, crunching all the transfers down to just 32 bytes, one transfer at a time, and the transfers take 3 months. So it's very, 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 very auditable, even though the money can be sent anywhere. And the good news is that, like all upper layers, if you don't want to use this idea, then you don't have to. You can just ignore it. To be a full node, you do have to check all of the rules. So at Bitcoin Core, after the soft fork, would have to keep track of like how many prisons there are, which outputs are prisons, and where each 32 byte is within the series of gates, but it wouldn't have to keep track of anything going on inside the prison. And so there's only a very tiny amount of full node overhead that's really, in principle, no different from check lock time verify or things that we've done dozens of times already, and that we plan to do dozens of times in the future. And so I'll just skip this part. So what I want to do next is contrast this hypothetical Bitcoin payment escrow from the example with the Lightning Network, because everyone loves the Lightning Network and knows so much about it. So I've outlined the process for number one, onboarding a new user, and then the user makes N payments to people to shop or something. And then finally, the user, they settles their remaining net wealth to layer one cold storage. So I try to make it apples to apples. And in assuming this process, I have tabulated here the total network transaction fees for each. And the Lightning Network charges a percent-based fee for payments, as does SideShift, ShapeShift, those things. So the Lightning Network, you need to pay more of those fees. You need to pay N of them. And the Lightning Network also needs to pay more of the layer one transaction fees, which will obviously be much more expensive per transaction than the ones in the large block sidechain, so to speak. So this comparison suggests that the Lightning Network will be cheaper when the magnitude of payments is very low, and when the absolute quantity of payments is very high. So it's Lightning Network is better for micropayments. And I think also, I've tried to tabulate the user experience here. I actually think if the user is willing to swallow that new security consideration, in other words, if the payments sidechain is popular, and that miners like having it around, so certainly not everyone will be comfortable with this new assumption, but I think many people will be. Certainly all the people behind Segwit2x probably would be. And if you are, you inherit a lot of advantages that are worth talking about. So in particular, you can get onboarded without a layer one payment, and you can receive money when you're offline or asleep, or if you're separated from your private keys, or if you're in a coma or whatever. So that's a big one. These other ones are maybe not as important. The main Lightning advantage is you get finality very quickly. So if buyer and seller are face-to-face and they both have their phones, then the Lightning Network's probably better, I guess. Okay, almost at the end of the talk. So the thing is that the payment sidechain is a good example, I think, because it sort of stress tests the idea for Drivechain, but scalability is not the primary purpose of the idea at all. The real goal is to neutralize these threats to Bitcoin, which are altcoins and hard forks. So there was 2 years ago, there was this thing Segwit2x that a lot of people construed as a threat to BTC, and I'm going to expand on that with the second point here, which is about boosting hash rate security in the long run. So currently, transaction fees on Bitcoin totaled $70 million last year, which is a microscopic number. It's really small. They need to be like 4 orders of magnitude higher, I think, 10,000 times higher. So we're nowhere near have enough. And the thing is, if you think that Bitcoin has competitors, it's unclear how the number is going to get much higher than it is today. So even if you think altcoins are dumb, and you're most certainly right about that, you have to worry about things. The hard forks are a bigger threat. You have to worry about someone makes an exact copy of BTC purely to create some more free block space. And that would be a decent competitor to BTC if you like BTC, because it would be exactly the same. So instead of one BTC chain, you just have a giant cluster of winning BTC chains. And if ever the layer one fees rise, then it would just stimulate the creation of new competitors. They'd all have low fee rates, low total fee revenues, and insecure hash rate. So with this, all the fees on all the chains go to the same miner, so the hash rate security is good. But the real point of the project is to bring cool new stuff to BTC. And I've just explained this payments escrow idea, so hopefully you think it has theoretically some value. We've got lots of new crypto. I mean, if you're a hardcore maximalist, you probably support Blockstream's Liquid network. There's a lot of cool ideas that are actually out there that a lot of people, I think, don't know about. One of them is this project, which is what I really care about. I don't really care about Drivechain very much at all. I'm only working on it to work on this project here, and you can see I got some cool endorsements and some very, very cool people up here. And I hate to rely on endorsements, but just not a lot of time to explain everything. But I encourage you to go to bitcoinhivemind.com and check out this video. The video's on there on the front page. And in general, I think that the space would be more fun to work in as well, and more productive if we had this thing to just let people carve out their own space to mold the consensus rules however they like without causing an inflation tax on everyone. So it's kind of related to these ideas from Nick Szabo that once a group reaches a certain size, there's just a lot of disagreement. We need some kind of pressure valve to get rid of that. And that is the talk. So I hope you enjoyed it. Thanks.